This is the solution to x400. Okay, so then to determine to determine if they're compositional inverses, we need to compose them. We need to confirm that when you compose them in both orders, you get the identity. If in either order you do not get the identity, then you can just stop. All right. So f composed with g, evaluate at x. Without the composition operator, that's f of g of x. So that would be 13 multiplied by slot plus 14. And what goes in the slot is g of x. So that would be 13 multiplied by, now g of x is x minus 14 over 13. And then plus 14. Continuing this up here, I see that the 13's cancel, so that we get x minus 14 and then plus 14. Now dropping the parentheses, I can see that the 14's cancel, so this is just x. So that means that when you compose them in this order and give it an x, then you just get the x right back. So that means that in this order, it's the identity. Okay, so that's good. But what about the other order? Let's check. So g composed with f, evaluate at x. Without the composition operator, that's g evaluated at f of x, which is slot minus 14 and then over 13. So in here, f of x. So this would be equal to, so in the slot it is 13x minus, no, plus 14, and then minus 14 all over 13. Well, if we drop the square parentheses, then the 14's cancel. Now the 13's cancel, and we get just x. So in both orders, the composition simplifies to x. So in both orders, the composition is the identity function, and therefore the answer is yes. They are compositional inverses. Okay, so part B is the same question, but with different functions. All right, so P composed with Q, evaluate at x. So this is P of Q of x, like so. So copying down P's formula would be 6 times slot plus 7. And then what goes in here is x minus 6 over 7. And, well, let's simplify it as best as best we can. So this would be, you know, you could write it like this: 6 multiplied by, say, 1/7 times x minus 6 over 7, and then plus 7. So that's dividing the 7 in. So this would be 6 over 7x minus 36 over 7, and then plus 7. So that would be 6 over 7 x, and then combining these together, this is 49 over 7. So 49 minus 36 is 13. So that'd be plus 13 over 7. Well, that means that for p composed with q, if you plug in x, then 6/7 x plus 13/7 comes out. Therefore, because that notably is not equal to just x by itself, therefore we can say no, they are not compositional inverses. Finally, we're asked a question about w. Is it possible for a function to be its own compositional inverse? All right. So then what we'll do is we need to compose w with itself. So w composed with w, evaluate at x. So that would be w of x. So that would be 13 over 14 multiplied by slot. So w of x goes there like that. Then we have 13 over 14 multiplied by now 13 over 14 x, like so. All right. So now these 14s cancel. So the 14s cancel, and we get 13 over 13 over x, like so. So now instead of dividing by that fraction, I'll multiply by its reciprocal. So this would be 13 multiplied by x over 13. Now the 13's cancel, so this is just x. And I don't need to check the other order because the other order is the same because they're both w. So the answer is yes. Therefore, yes, w is its own compositional inverse. And when something is its own inverse, that it's not necessary for our class, but it might be interesting for you to know that such a thing is called an involution. So it's a thing that's able to undo itself.